Okay, a projectile is fired straight up from the ground. It reaches a maximum height of 101.25 after 4.5 seconds. Then it falls to the ground for another 4.5 seconds later. So from the question so far, we have to identify the given information. The word ground is an indicator of information. That's looking at some type of value of 0. A maximum height, we know that's going to relate to our vertex. We have time, so our x-axis is going to be time. Our y-axis is going to be height since it reaches a maximum. And then 4.5 seconds later hits the ground. So it's given us two numbers there. So we have several pieces of information before we get going. So we know that our parabola, because it starts on the ground, goes into the air, and comes back down, we know it's opening down. So we know our a value is going to be negative. We know our two x-intercepts because it starts at time 0 and it starts on the ground. And we have that it reaches the ground 9 seconds later. And we know that because if it starts at 0, 0, it's saying in 4.5 seconds it's reached its maximum, and then another 4.5 seconds it's reached the ground again. So that's where the 9s come from. And then that gives us our vertex that at 4.5 seconds it's reached a maximum height. So now the question asks us to write a relation for this parabola and then state the form used. And this is where the thinking process comes in of which formula do you want to use. We have two sets of information, so we can clearly use factored form or vertex form, but we're still missing the value for our a. So again, either one, I'm going to go through both approaches. If I start with my factored form, y equals a x minus 0, x minus 9. We can simplify that to just x and x minus 9. So now what can we use for x and y? Well, we have the vertex. So let's plug in the vertex and solve for a. So we have 101.25 equals a is still unknown, 4.5 and 4.5 minus 9. So again, working things out on your calculator, you have 101.25 equals a. 4.5 subtract 9 is negative 4.5 times 4.5 is going to be negative 20.25. And again, this is all calculator work. You're going to divide both sides to isolate our variable. And that's going to give us that a equals negative 5. So that confirms with what we had before, that we knew that our a value needs to be negative, so it's opening down. Let's see if we get the same doing it the other approach. So if we decided to start with our vertex, we'd have y equals a, x minus 4.5 squared plus 101.25. I'm going to use the vertex. I'm not going to use the vertex this time. Instead, I'm going to use 0, 0. So here at the beginning of our parabola, we know it's at 0, 0. So I'm going to plug in 0, a, 0, minus 4.5 squared, plus 101.25. So if we start simplifying, we have 0 equals a negative 4.5 squared plus 101. We need to isolate a. So again, we want to leave a alone and you want to start removing things to the other side, so you're isolating for the variable. So I can subtract both sides by 101, so I know when I move it over here then, we've got negative, in a we've got negative 4.5 squared. You're going to divide both sides by 20.25, and a again is negative 5. So if you had used your vertex and up here and you had plugged in 4.5 and 101.25 for your x and y, everything you would have gotten a value of 0, and that has to do with how when you're at your max height, there's momentarily that 0 speed like we watched in that football video. So best to use either one of the x and y coordinates that we have, and they will both work out to having a value for a. So then I could finish the question, and just by subbing a back in and write my formula, let's just find another. So if I was to answer it, I would have, again, either form, and we'll just say the factored form is y equals -5 x minus 9. I could state it's in factored form, and I would have to say when y is the height and when x is the time. And you can use h and t those as well. So what is the height of the projectile after 3 seconds? Is there another time when the projectile is at the same height above the ground? So time is 3 seconds, so you're going to replace your x variable or your t variable for 3 and find out what the height is going to be. So at 3 seconds, which would be before, what's this height? Is there another time when the projectile is at the same height above the ground? And there will be, because it's a parabola, so we know it's symmetrical. And with the material that we've covered so far, there's 2 approaches, but the easiest approach right now would be if we know the height at 3 seconds, and we know the height at 4.5 seconds, and we know that it's symmetrical. So the difference between 3 seconds and 4.5 seconds is 1.5 seconds. So 1.5 seconds past its max would be at 6 seconds. So I can do the same procedure, and I can plug in 6 for my x variables to find out my height at 6 seconds. And again, for what we've covered, we're going to take out C.